Right, so now that we've gone through and we've talked a little bit about our different shapes of distributions, what we are going to focus on is going to be something called the normal distribution. The normal distribution, or sometimes referred to as a Gaussian distribution, named after a mathematician, is one of the most important shapes and most important types of distributions we're going to see. Many sets of data are normally distributed or actually close to a normal distribution. A graph of a normal distribution is called a normal curve. The normal curve is bell-shaped, right? So it's bell-shaped symmetric. It's unimodal, meaning we have one mode in the middle at our highest frequency, and symmetric about the mean. Right? So this is an example of a normal distribution. Right? So it's bell-shaped, it's unimodal, there's one mode in the center, and it's symmetric about the mean. The tails are pretty even on both sides. One of the reasons that this is such an important distribution is the mean, median, and mode of the normal distribution all have the same value and all occur at the center. So looking at this, that means unlike our skewed distributions that we saw before, right here in the middle, right, that is where our mean, our median, and our mode all live. It's also worth noting normal curves with smaller standard deviations are taller and narrow, and normal curves with larger standard deviations are shorter and wider. They're more spread out. Okay? So what we're going to look at in the example below is just kind of visualizing a little bit with our mean and our standard deviation of a normal distribution. All right, so in this case, we see two curves. One is taller, one is shorter and wider. Right? In both cases, if we were to draw a dotted line down the middle here, it looks as though we're going down the middle of both of these curves. That means that both distributions in this image have the same mean, but since they are different heights and they are, taller and skinnier, wider and more spread out, right? They have different standard deviations because standard deviation has to do with spread. Now, if we compare that to this image down here, these are the same height, right? So both distributions in this image have the same standard deviation. Because they are the same height and spread, but they're shifted to the left and to the right. Right? Our mean for the women is around here, and the mean for the men is around here. So they have different means. So comparing relationships to one another, comparing heights of our curves based on our standard deviations is something that is definitely going to be a factor when we're looking at and calculating things about a distribution or comparing different distributions.